Okay, let us solve some of the problems. Uh, we are just concentrating on only gate questions. So let us see some problems. So let us solve the problems. Here I'm giving one gate problem in the data structure. If if the if the input if the input sequence if the input sequence is 1 comma 2 comma 3 comma 4 comma 5 4 comma 5, then identify a valid or we can say let us this is invalid stack invalid. I'm adding some more options actually so that to make stack permutations. Invalid stack permutation. So this is the sequence. If the input sequence is 1, 2, 3, 4, 5, then identify the invalid stack permutations. Here options, we have some options. Okay. Option A is 4 comma 3 comma 5 comma 4 3 5 comma 2 comma 1. So this is a one stack permutation. And let us take for one more option B. Now see here B option is 3 comma. Now you try to solve parallelly. Okay. So take this problem and try to solve that. And meanwhile 3 comma 2 comma 4 comma 5 1. So this is option B and option 3 2 4 5 1. Next option C is 3 comma 5 4 and 2 comma 1. And let us take one more option D. 5 comma 4 comma 3 comma 5 4 3 2 comma 1. And let us take one more option D. It is here 4 comma 5 5 comma 3 comma 1 comma 2. So now try to answer anyone. Just if the input sequence is 1, 2, 3, 4, 5, then identify the invalid stack permutations. Invalid stack permutation. So I'm adding one more options as okay. Here D option is E. Here, okay. Let us take option is E. Can anyone tell me what is the correct answer? You just try it and otherwise I will explain you. Don't worry. From your side, you try to tell. This problem, what is the answer? What is the correct stack permutation? Anyone? What is the stack operations of basically, first of all, stack normally we have a push and pop operations, right? Now you try to see that permutations means the given normally sequence is 1, 2, 3, 4, 5. So, but in this here, I'm taking a some stack permutations here. Okay. So that means stack permutations means some operations on the stack. So whether it is a correct or valid permutation or invalid permutation, you tell me. Anybody got answer? So I want to identify invalid permutation. Okay. I think no one is giving answer. Those who are joined late also you can see, try to observe that. So this is a given question and you try to answer this question. Okay. What is a correct stack permutation? What is the invalid stack permutation? So we know that stack is perform push and pop operations basically. So let us take one stack here. It is very easy one actually. If you are not just by seeing the question, you will not get it. If you try to apply this one, you can able to easily get it. Okay. Otherwise, if you simply so you take the stack and you see here, this is a stack I have taken. And what is the input sequence? I'm taking 1, 2, 3, 4, 5. Okay, let us see that. First, A. We have to always check the options. For the gate exam, you based on given options, you have to try to answer the questions. Okay, not on your own. So the given options are like this. Okay. So now let us take first. I will perform the push operation of 1. Okay. Next, what is the operation I will perform? I will push one more operation, that is a 2, because the sequence is like this. Next, what is the one more operation I will perform? 3. Okay. Push operation on 3. Next, again push off 4. These are the push operations I am performing, right? So now I want stack permutation here. See here, 4. 4 means you need to pop the topmost element. Pop అంటే ఏంటండి? You need to remove the topmost element in the stack. So here 4, the out of the sequence is 4. Okay. 4 is next again perform the pop operation. So next 3 will be again perform the, now see here is sequence 4 and 3 I got. And what is the next one? In the option A, what is the next sequence here? Next sequence is what? 5, right? 5, and already the 4 and 3 already removed from the stack. Removed from the stack. And what is the topmost symbol of the stack? 2. And next element I want to insert is 5. So perform the push operation. So what is here? Perform the push operation 5. Now you can pop topmost element. What is the topmost element of the stack now? 5. So it will be next sequence is 5. Next sequence is 5. And the next, so after 5 is removed from the stack. 5 is removed from the stack. Now what is the remaining the topmost symbol of the stack? 2. Now next one is 2. 2 will be removed. And the next, after removing out 2, what is the next last symbol that is there? Now 1. So 1. So whether it is a valid A option, option A is a valid sequence or invalid sequence? Answers. I am expecting answers. Okay. So this is a 4, 3, 5, 2, 1. So that means here the options are 4, 3 here. The sequence that the elements are getting deleted is 4, 3, 5, 2, 1. So option A is actually valid sequence, I can say. Valid sequence. But I want invalid sequence actually. Invalid stack permutation I want. But this is actually correct, valid. This is called valid stack permutation because I got option A is a valid stack permutation. Valid stack permutation. Okay. Next, coming to B. Now, can anyone tell me whether B is a valid stack permutation or not, or invalid stack permutation? Try చేయండి. A already I explained, no? Now try to do it for the B. What about option B? What about option D? Please give me the answers. Option B is a valid permutation or invalid permutation? Same apply. Apply similar way. Similar way you try to apply here. So coming to B, what is the normal sequence it is? You see here, those are join left. 1, first push operation on 1, next to 2, next to push operation of 3. So now over you see here, it is started from 3. So you have to remove the, now you have to perform the pop operation. So perform the pop operation. That means pop. So that means 3 will be, what is the topmost symbol of the stack? 3. So 3 is getting removed. 3, 3 comma, and next 2. 2 is removed. Next 4, but 4 is not there actually, right? So that's why 3, 2 will be removed, and 3, 2 will be removed. Topmost stack is 1. So if I perform the pop operation, 1 I will get. No, now what I will do? I will perform the push operation. What is the push operation? 4. Again, now 4 only, not 5. Okay. Now again perform the pop operation. So that pop operation means 4 is getting removed from the stack. So here 3 comma 2, 4. And after removal of 4, now again what is the sequence? Sequence is now 5 will be 5. 5. Now you can perform the push operation. 5 is done. Again perform the pop operation. So pop operation means which element is come out of from the stack is 5. 3, 2, 5. And finally what is there? Topmost stack, last one is 1. So this is also a valid stack permutation. Valid stack permutation means on the stack, what type of whatever the operations you are performing, whether you are getting this sequence or not. That is a main thing. So option B is also a valid valid stack permutation. Similarly, option C and D. You check it here. C. Option C is also option C. So let us check for the option C. This is option A. This is option A. Option A. This is option B. This is option C. Actually, okay. So let us see. So again, quickly tell me, C is a valid permutation or invalid permutation? At least tell me now. Can anyone answer? C, D, E, which one is a valid permutation and invalid permutation? Work out, change it. Please try to work out. It's a very important problem. So again, start like this. Perform the push operation. One sequence will be 1, 2, 3, 4, 5. That is the sequence. That's why we have to follow that one. 1, 2, 3. After inserting 3 elements, next it is starting 3, right? So I need to perform the pop operation. What is the pop operation? So pop operation means the topmost element will be removed. So what is that element is coming? 3. 3, comma. Again, next, what is the element here in the sequence? 5. So in order to get 5, what you have to do? So inserted 3 is done. Next 4, again 5. Now you try to perform pop operation. What is the pop operation means? 5. Now the element is removed is 5. 3, 5. And what is the next one? 3, 5, 4. So because 5 is removed, then it is 3 only, 4 only. So option 4 is there. And after 4 again, there is a 2, 1. See here, 2, 1. That's it. 2, 1. This is also a valid stack permutation. This is also a option C, also valid stack permutation. So option C is also a valid stack permutation. Next, coming to D, option D. Option D. You check it here. It's a valid stack permutation or not? Option D. D is also a valid permutation. Okay. Okay, let me check. So, option D. Option D, quickly I will do. So, first one, push operation, two, push operation, next three, four, next five. So you try to perform the all pop operation now. So what is 5, 4, 3, 2, 1? That's direct option is that D is also a valid stack permutation because you perform 5, 4, 3, 2, 1. So no issue. No, this is option D is also valid stack permutation. And what about EMA? What about E? Whether it's a valid stack permutation or invalid stack permutation. Invalid. Okay, good. Few people are giving responses. Only few people. Remaining people are not at all solving. So option E is actually invalid stack permutation. Okay. Let us see that. Why it is an invalid stack permutation. We'll see that. So what is our option? One, we will perform the push operation. Two, three, and four. After four, because we need to perform the here you because I need to get the four. So what I will do is four is means pop operation. So four is pop operation. Four comma next what is inserted element is five. So after four, what we need to insert? Five. So five will be inserted. That means push operation. Now this four is removed. Okay. This four is also here removed. And now topmost symbol of the stack is 5. 5 also removed. 5 also getting removed. So what is here? 4 and 5. Fourth 5, comma. And what is there in the topmost symbol of the stack? 3. So now 3 is also removed. Now, okay, up to here, we don't have any issue. Okay. It is perfectly all right. Now, after this, what is the topmost symbol of the stack? 2. But you check here 5, 4, 3. Sorry, 4, 5, 3. After here we got 1. So how do you get 1? Is there any chance of getting 1? No. Topmost symbol of the stack is only 2. You should get only 2, not 1. In the sequence after 3 here, you will definitely get only 2. So this is a violation condition. So that is why this is a invalid stack permutation. This is a invalid stack permutation. So this is a very important one. Okay. This is application of stack. Most of the times we know that what is a stack means push operation, pop operation, but there is a problems if you solve, and there is a chance of getting a gate questions like this. Okay. And previously we got like this, one of the previous gate problem. Okay, let us take one more problem. I hope it is understood. And if you have any doubts in this problem, you can ask. Otherwise, we will go for the next problem. So here, what is the option is? Option is invalid stack permutation. Invalid stack permutation means option E is the correct option for that question. For this question, option E is the correct answer. For this question, option E is the correct answer. Okay. Let us take one more problem. One more gate question. One more previous gate question. What are the what are the what are the top two elements of stack after evaluating after stack after after evaluating first star. What are the top two elements of the stack after evaluating first star? So that means I'm giving sequence here. Okay. But in the question, we have a sequence. Here, this is the question. So what are the top two elements of stack after evaluating first star and okay. So in this, I'm giving some sequence also. 8, 8 comma 2 comma 3 comma, and there is a one more here we are having symbol 8 comma 2 comma 3, and it is a power symbol. Okay, you see here it is a power symbol. After that, power symbol. This is represent power symbol only. Okay, 8 2 3 power symbol, comma again division symbol, like this division symbol, comma after division symbol 2, input sequence will becomes 2 2 comma 3 comma, and the next symbol is a star, comma plus symbol, and after that 5, and after that 1, and again star, and again after star again plus. Now here the question is what? After evaluating first star, what are the top two elements of the stack? What are the top two elements of the stack? That means where it is a first star means the first star is here we need to get. Here, this is a up to here. This is the first star or we have encountered in the sequence. Yes or no? So now this type of elements, how we need to evaluate? What are the elements of the stack after evaluating your first star? After evaluating first star, can anyone tell me what is the answer? Try it just take a 2 minutes and try. Here there is some concept is involved. Okay. Now tell me here when you are aware, whenever I will explain you. Okay, at least I will explain you concept at least and tell me that after that at least. So what is this? One is so this is also a previous gate question. So every previous gate question. Okay, options also I will give you. There is gate questions are very easy with the condition that you need to know the concept. If you know the concept and if you apply properly, then these gate questions are not that much difficult. Option A, option A is 1 comma 6. Option B is 7 comma 5. And option C is 5 comma 1. Option D is 2 comma 3. Option D is 2 comma 3. Now, what are the top two elements of the stack after evaluating first star? Now tell me, can anyone tell me? Now you tell me the sequence. The given sequence is, first of all, whether it is a what type of sequence. 8, 2, 3 power symbol, division symbol, 2, 3 star plus 5, 1 star means the given sequence is what type of sequence? Whether it is a postfix notation or prefix notation. At least tell me that one. This sequence. The given sequence is a postfix notation or prefix notation. Just tell me. I'm not asking you a difficult question. The given sequence is whether it's a postfix notation or prefix notation. The given sequence is a postfix notation. And the given sequence itself is a postfix notation. See, postfix notation, let's take, we have a 6, 6 minus 2. There is a 6 minus 2 is there. Okay. 6 minus 2. So how can you write this 6 minus 2 in a postfix notation? 6 comma left and comma right. What is the right is 2 comma operator. Yes or no? What is operator? Minus. So this is 6 comma 2 comma minus is a postfix notation. Suppose if you write this is a postfix notation. Okay. Suppose you want to write in a prefix notation. Prefix notation. How you will write the prefix notation? Same thing. It is a minus. Symbol is minus and the left hand side is 6. Right hand side is 2. So this is called a prefix notation. Okay. So here plus and star is there, last. So based on that, I can say the given sequence is a postfix notation. Whenever it is a postfix or prefix notation, the evolution should be, we need to know what is the evolution. You need to know that. So in a postfix notation, you will try to observe here. In the postfix notation, let us take 6 to the evolution you see here. The evolution is first, what you are performing? 6 and 2. 6, 2, and after that 6, 2, and you need to perform the minus symbol. So whenever there is a minus means you cannot insert the minus into the stack actually. That is the invalid. So minus means whenever there is a minus means you have to perform the operations of the last topmost symbol of the stack. So now that means which argument I need to take first and which argument I need to take the second. That is a difficult one here in the gate questions. Okay. So suppose in this one, which one I need to take? Topmost postfix notation means topmost will be the second argument. Topmost element is second argument. Second argument. In which notation and postfix notation? In postfix notation. Okay. In postfix notation. So now you see here. Now topmost symbol of the topmost argument is second. Topmost element is second argument. That means what? The 2 will become second argument. That means what is the answer here? 6 minus 2. How to evaluate here? 6 minus 2. Answer is 4. Like this we need to evaluate. Suppose if it is a prefix notation. Suppose the given sequence is a prefix notation. The given sequence is a prefix notation. So we need to see here. First, minus and 6 comma 2. Minus and 6 comma 2. In this, tell me, you have any doubt in the prefix notation? If you have any doubt, you can write. I will explain you. So, in the prefix notation, topmost element is first argument. In the prefix notation, topmost element is first argument. In the prefix, topmost element is element in the stack is first argument, not second argument. Okay, this is the difference. First argument. So now you try to answer easily. So now the given expression is a postfix notation. Now you try to answer for this gate question. Try to answer it. First to compute 8. 8 means push operation. First I will start with 8. Next 2. Next element is 3. Now what is the operation ma? Power symbol. So whenever there is a power symbol means what is here? The topmost will be the second argument. Topmost will becomes the second argument. Now what is the answer? Second argument means the topmost is the second argument. That means what? 2 power 3. Yes or no? The power symbol means here whenever the power symbol means 2 power 3. 2 power 3. So topmost symbol of the stack is here second argument and this becomes a first argument. So this top 2 elements will be evaluated power of. So 2 power 3, answer is 8. Answer is 8. So now topmost symbol of the stack is, what are the elements and 8 initially here, 8, and after evaluate 2 cube means what is the answer? 2 cube is also answer is 8. Option is 8. Okay. Now, what is the next operation? Division symbol here. Next operation, what you need to perform? Here it is a division symbol you need to perform. Division symbol means what are the top two elements of the stack? 8, comma 8. Now you try to perform the division symbol. So what is that? 8 by 8. 8 by 8 means what is the answer? After performing division operation, the stack becomes now 8 by 8 is answer is 1. So the answer is 1. Okay. Next. Now insert the next after division. What is the symbol next again? 2. Now perform the operation 2. Again after 2. Again push 3. Push operation of 3. Again after 3. What is the symbol? Star. Star means 2 star 3. So now what are the topmost elements of the stack? 2, 3. Now I need to evaluate star operation. So 2 into 2 into 3. 2 into 3. What is the result? 6. 2 into 3, 6. So after evaluating first star, what are the topmost elements of the stack, Andy? What are the topmost elements of the stack? 1, 1, and 2 into 3, 6. 6. This is the answer. This is the answer for this question, actually. Okay. So option A is correct option. Option A is correct option. That means after evaluating first star, so what are the topmost elements of the stack? Is 1, comma 6. 1, comma 6. This is the correct answer. Okay. For the same question, actually linked answer. What is the result after evaluating entire result? After processing entire sequence. Okay. Now continue. And can anyone tell me, continue the same process and tell me after a result. Now we have evaluated first star, right? Next go for the plus and 5, 1 star plus. Now what is the final result? Tell me. What is the final result? I am giving options also. After evaluating entire thing, I am giving here, uh, I am giving here option A. After evaluation entire result, option A is minus 12 and option B for this question is on option A is correct. Next, now the next same question I am continuing. After evaluation, after completion of this sequence, what is the result? Option B is 14 and option C is 12. Option D is minus 14. Can anyone tell me what is the correct option after evaluating entire result? Try to work out and tell me. Can anyone solve here? What is the result after evaluating entire sequence? Now we have done up to first star. Next, perform the plus operation. Okay. Next, perform the plus operation. Plus operation means what? 1 plus 6, right? 1 plus 6 means what is the answer? 7. Answer is yes, 7. After evaluating first here plus answer is 7. After 7 again, element to be inserted is 5. What is the next sequence? 5, right? 5. Again, what is the next element to be inserted? 1. Now try to perform the here second star. After in the sequence, second star here. So after second star is evaluated, 1 into 5. What is the answer here? 1 into 5. So it becomes 7. 7. Here 7 and 1 into 5 is 5. So next plus operation. Okay. After again try to perform the plus operation. 7, 5 is option is here after evaluating entire sequence. What is here? 7, 5. 7, 5. 7 plus 5. 12. 12. So which option is correct? Option for the second question, option C. Option C. After evaluating entire sequence, what is the answer? 12 we got. So this is what the given problem. So these are the questions will be asked from the concept of the stack in the previous gate questions. Okay. Okay, done. Any doubts in this one? In this question? If you have any doubt, understand, or you have any doubt? If you're not having any doubt, we will go for the next one. At least give me the responses, whether you understand or not understand, so that or somewhere you are not understand. If you ask the question, it will be easy. Okay. Okay. Next, we will go for the one more problem. Okay. Okay, prefix also, na? Okay, very good. So for the same sequence, tell me the prefix also. Very good. Okay, take the same sequence and we will try to do prefix. So let this sequence, let us, we are assuming that prefix notation. So let me take this. Prefix means what? The topmost element will be the first argument. Topmost element will be the second argument. Okay, let us take for the same thing. Let us assume that. So these are the prefix, and we will do here. Okay. Tell me the result of for same thing. Tell me what is the result of the prefix. They will ask you like a prefix. So take the stack elements here. 8. I'm just taking this sequence only. Okay. Let us take this sequence wise. 8, 2, and next one is 3. Okay. And what is the power symbol now? In this power symbol only we will get a difference. Remaining all are same only. Okay. Power symbol means what? Here topmost element will be the first argument, whereas the postfix notations, topmost element will be the second argument. You see here, prefix means topmost element in the stack is the first argument. So topmost element of the stack is first argument. That means here in the previously we have evaluated 2 power q, but here topmost element will be the first argument. Now when you are evaluating first power symbol, it will becomes what? 3 square. It will become what? 3 square. 3 square. What is 3 square means? 3 into 3, answer is 9. So after evaluating here, power, we got like this. Okay. 8. 8 is 8 is here. And we are having 3 square means it is a 9. So now again, what the next one operation is? Plus operation. After immediately star, it will be the plus. Plus means if 9 will be the first argument or second argument, it doesn't matter, right? Only when it will give the difference powers, when you are there power symbol, the first argument and second argument makes a difference. Otherwise, here 8 plus 9 or 9 plus 8 will becomes both are same. So this will be the 9 will be the first argument and 8 will become the second argument. That means 9 plus 8. Okay, 9 plus 8. What is the 9 plus 8 means? Answer is 17. Answer is 17. Understand? What is the difference between postfix notation evaluation and prefix evaluation? I hope you understand. 17. And if you want to continue, you can continue. Okay. Again, 2 and perform the 3 and like this. Okay. And evaluate here, start. Okay. I'm taking actually this sequences. I'm taking same sequence. Okay. If you want other sequence, you can take, but the idea is like this. Okay. It will be changed in the prefix is topmost element in the stack is first argument. In this postfix means topmost element in the stack is second argument. That is the only difference. Nothing remaining, everything is same. Okay. So like this, you can evaluate the first infix notation like this, and postfix notation will be this one. These are the two major differences you need to understand. Write down this. In the prefix, topmost element in the stack is first argument, and postfix means topmost element will be the second argument. Understand? Clear and without. Okay. How we can identify? Okay, the given problem is a prefix or postfix. Yes. Starting only, I have explained this. You see here, how do you identify? So the given sequence is, suppose if they will not mention whether the given postfix notation or something, sometimes they will give you without mentioning also, okay, right? By identification is very easy. You see here, whenever there is a, here see, if plus is present last, then we can say it is easily postfix. Simply, what is evaluation? Postfix means what is evaluation? Always postfix means what is the notations here? We have a infix. Infix. Infix means what? Left and root. These are what? Three notations, right? Left to root to right. This is a sequence. Left to root right. Or in this one, left means suppose you want evaluations 2 plus 2 plus 3. 2 plus 3. This is called infix notation. Okay. This is infix notation for the prefix. Suppose if it is a prefix means, prefix means, prefix means what? First root, that means the root or operator here. Okay. In this, we can say operator or anything. For the tree, I am just writing root, or we can say operator also. Left to right. Left to right. Similarly, suppose for the same expression 2 plus 3, how can I write? A prefix notation means plus. Plus 2, 3. You see here, plus 2 comma 3. Plus 2, 3. Here you try to observe, plus is coming before. Then I can say that it is a prefix notation. Suppose for same thing, I will write a postfix. Postfix means what? Postfix. Left to right and here root. So here in place of root, I can say any operator also if you want. Same expression 2 plus 3. Tell me the postfix expression. Left is 2 and 3, 3 and plus. Now you try to observe here. So by just sequence, you see here, finally it should be a plus. Finally, it should be a plus. Then we can say whenever there is a plus is the last, we can say it is a postfix notation. There is a postfix notation. Whenever it is a some operator is in the starting, then we can say it is a prefix notation. Like this, you need to identify. So in this sequence, you see here plus star, almost two are the operators that are available in. So I can say simply it is a postfix notation. Postfix notation. For the same thing, suppose you want prefix notation means this plus and star will come here you. The plus will come definitely in the first, like this. And this sequence also is going to change anyway. Okay. Understand? How do you identify whether the given sequence is a prefix or postfix? That is very easy. It's not a big issue. Okay. Very good. Okay. Next, like this, we can solve some more problems. If you ask doubts like this, it will be, good. That means you are learning. If you are not asking doubts, means you are simply sitting. It's a waste of time. Okay. Let me solve one more problem. Okay. So I think for this, based on this one, very interesting. One more gate question. Data structure is a very good subject in the gate point of view, especially. So let us take pre. I am giving generate the post order traversal for a given. Generate post order traversal. Generate the post order traversal a given for a given sequences. Okay. Question is this is question. Okay. Generate the post order traversal for a given sequences. I am giving sequences. Okay. So I am giving prefix notation and I am giving prefix notation. The prefix notation is A, B, C, D, E, F. Okay. And I am also giving in order. These are all what tree traversal techniques and okay. Prefix, postfix, infix, in order. In order means B, C, A, E, D, F. Okay. B, C, A, E, D, F, A, B, C, D, E, F. Okay. So these are the two sequences I have given. So first sequence is the prefix sequence and infix I have given. Now I am asking what? Post order. I want to generate post order traversal. Okay. Post order traversal and I'm giving options also. Okay. Option A is C, B, E, C, B, E. We'll give some C, B, E, F, F, and A, D. This is the one option. And is one more option is C, B, E, F, D, A, and C. One more option is B, C, A, D, E, F. And option D is none. Option D is none. Option D is none. None of the above. That means none means. Tell me. I already given pre-order as well as post-order. Sorry, pre-order and in-order. Now what I am asking? I am just asking for the post-order. whenever this type of gate questions are there, see, if they will give you infix, infix plus postfix, postfix, you can able to find out the prefix, prefix. Or if they will give you infix plus prefix, you can able to find out the postfix, postfix. These are the standard notations, okay? If you know infix notation, postfix notation, you can able to find out the prefix notation. If you are know that infix plus prefix, you can able to find out the postfix notation. Now in this already infix prefix is given. Now I need to find out the postfix. That's the second way. Now just now I have given that. So already left to root to right. So in the prefix notation means first what is there? A is there. A is there means what is A? A is a root node. A is a root node. Yes or no? Because root is always first. So in the root node, A becomes the root node. That is a clear. And infix law, in the infix notation, the root is present in the middle. Root is present in the middle. So this A is here in the middle. So here left hand side part is left subtree and it is the right hand side part is the right subtree. First to generate the tree so that you will get the sequence later. Okay. First generate. So A becomes a root node. That is the we got very clearly. Okay. A becomes the root node. A becomes the root node and left hand side is A becomes the root node and left hand side part is BC and right hand side part is EDF. Okay. In the left hand side is also, in the left hand side, what is BC? In the BC also, which is the first one? Which is the first one? B becomes the first one. That means B is the root one. In the BC also, in the BC, left hand side, you see here. In the left hand side, this BC. In the BC also, which one will become the root? Either C is the root or B is the root. How do you decide? So based on prefix notation, you see here, B is coming first. So I can say that B is the first one. B. B is the root node. B is the root node. After B, you see here, C is present in the left hand side or right hand side? C is present in the right hand side. So that means after B, C is present the right hand side. From the B, the C is present right hand side. You see. So here I can say that, here I can say that B is right child of the B. Very good. That's the left hand side part is I have completed. Now coming to right hand side. What is the right hand side for the A? EDF. EDF. So in the EDF, which one will become the root? Which one will become the root? So D will become the first root actually. You see here in the DEF, which is present in the first D. So this D is the root. D is the root means D becomes the root node. D becomes the root node and I already given infix. For the D, you see here, for the D, left hand side is E, right side is F. No issue. Okay. Left side is left side, left hand side of the part is E. Left side of the node is E. And right hand side part is, and right hand side is F. And right hand side is F. So left side is E and right hand side is F. Now this is the tree I have generated for the based on prefix and infix notation. Now postfix notation directly I will get it. So I will tell you shortcut for generating prefix or postfix notation for the given tree. If they will give you tree, you try to always explore like this. In gate exam, there is a node. This is the node. Node left child. This is the left child, and this is the right child. Let us take the right child. This is node. This is a node. This is a node, and the left child. This is the left child, and this is the right child. Left child, and it is right child. This is node, left child, and right child, right? So you try to observe here carefully, okay? For this node, first visit. For this node, first visit is this is a first visit, and this is called first visit. See here. This is a for this node, this is a first visit. For this node, this is a first visit. And this is a here. You come to here like this. So you come to here. Like this, you traverse first visit. Now after coming to this one, again this place. This place is a second visit of this node. This is second visit. Second visit of this node. And like this, you can go here. And this is a third visit. This is a third visit of this node. Same node, I have visited first, second, third. Why I'm telling this shortcut is, so for any node, if you want prefix means you need to consider the first visit. Okay, for prefix, I will write here. For prefix, you need to consider first visit. First visit. Similarly, for the post, for the or infix, we'll say. For infix, for infix, for infix notation, you need to consider second visit. Second visit. For if you need suppose postfix sequence, if you want to know the postfix means third visit. Third visit. Okay. Now you tell me postfix for this tree. Postfix for this tree. Third visit you need to consider. Okay. Third visit. Third visit. These shortcuts are very important. See here in this left hand side, nothing is there. Okay, null. So first visit, first visit is came. Okay, I don't want all the first visit. I want only third visit, right? So postfix means okay. Now coming to B, B is also first visit. Now after that here it is came. It is a second visit, and next I traveled to C. C for the because it's a leaf node. First visit, second visit, third visit is also same thing. So here C. Now what is the first? In the postfix one is third visit is completed. So first is C is explored. After that, C for B, what is the how many visit is it? It's a third visit. So now third visit means now you check here C B C B. Again, after that, A is the only second visit only. Now come to D. D is the first visit. E is the first visit and second visit, third visit also. So now it becomes E. C, B, E, and after that D. D second visit only. For F, First visit, second visit, third visit, all are same. You see here because it's a leaf node. So F, F in the sequence C, B, F, and after that F again D. D is also third visit. D is a third visit. Again, finally A is a third visit. This is the postfix notation. Which option is matched? C, B, E, F, D, A. Which option? C, B, E, F, D, A. Option B. Option B is the correct option. Option B is the correct option. Right? So this is very easy one. If they will give you prefix and infix, you can find out the postfix. If they will give you postfix and infix, you can find out the prefix notation. But if they will give you prefix and postfix notation, you cannot find the infix notation. It is not possible actually. Maybe some trial and error you can do it, but you will not get exactly, and they will not give that one also. Any doubt here? And by seeing options also, you can eliminate options. How can you eliminate options? Just by seeing, observing options. You see here, A is a root node. A is a first present. If A is a, okay, luckily options, actually without solving also, you can able to answer this question, okay? Because option E, for any postfix notation, this A should be present in the last. Here D is there. Just close this one. Remove this option because D is last. No, it is not possible. A is the only last because for the postfix notation, the root node is present in the last. Okay. So, and here F, it is also wrong. So option B, without constructing tree also sometimes, you can give the answers. But maximum they will not give you like this. Okay. Here actually I changed options. Okay. This is one possible question for gate question, and also previously it is asked. And if you have any doubts in this question, please ask me here. Any doubt or anything you want to modify here or like this, or anything I need to explain here, you try to ask. Okay. Tree to prefix. So okay, I will write this for this tree. I otherwise will take some different tree because it's already prefix is there, infix is there, no? We will take different tree and I will write all the infix notation, prefix notation, postfix notation. So all I will write. Okay. Okay. Let us Okay, he's asking that. We will take one tree and we will write all the notations. Let us take one, or letters only take. A or letters means so. Two, and let us take one. I am taking normal tree, normal just here. I am not taking any binary search or anything. General tree I am taking. Okay, don't think about all those things. Okay, four, 12, this is a tree. 9 is the root node. Something you can take anything, letters or anything. No issue. 5, here 9, 8, you can take. Anything is okay. Single digits I am taking so that it will be clear. Otherwise, you will get many confusions. So 5, 4, 3, and 2, 1. So just I am writing directly. You see here. First I am writing prefix notation. Prefix notation. Prefix notation means you see here. Try to see here. First, start from the root node. First visit. Yes. Prefix means you need to take always first visit first. Okay. First visit node. 9 is the first visit. So take 9. And next come to here. 9. After 9, you will come to here 5. And the 5 will becomes the first visit. And write on the sequence 5. And again after that 5. After 5, again the first visit will become 4. So write down the sequence here. 4, 9, 5, 4. Again, after 4, this is a for this. These are all first visits. And this 5, second visit. This 3, first visit, second visit, all are same, right? So now next one is 3. 3. And again, after 3, after 3 is completed, 5 is third visit, 9 is the second visit. Now come to here, 8. 8 is the first visit. For this one, prefix means 8. Now again, 2. 2 means first visit. For the first visit, 2. Again, after 2, first visit, second visit, all are same for the 2. Okay. Next, 8. 8 is the second visit. Again, first. 1. 1 is the first visit. 1 is the first visit. 1 is the first visit. Again, here for the space 3, 8, 9. 8 is the third visit. 9 is also third visit. Now that is a prefix. Prefix. This tree, the prefix sequence is that. Prefix sequence is that one. Okay. Next, similarly, you try to write down the postfix. Postfix. Similarly, postfix. How do you write the postfix means? Third visit. Postfix means what? Third visit. What is the third visit? Third visit. You try to see here. 9. 9 is the first visit. 5 is the first visit. 4 is the first visit. 5 is the second visit. 3, sorry, here. 9, 5, 4. 4 is the first visit, second visit, third visit. So that means that 4 I am going to start. 4. And after that, after 4, 5. 5 is the second visit. Again, 3. 3 is the third visit. 3 is the third visit. 3 is the third visit. Again, 5 also third visit. This is the first visit. Here it is the second visit and third visit. So third visit is what? 5. Next to 5 is the third visit. Again, like this, 9 is a second visit only, 8 is the second visit, 2. 2 will become first and second, third. So it's a 2 is the third visit. Again, 8 is second visit, 1. 1 is the third visit. Again, now 8. 8 is a third visit. And finally 9 is also third visit. So this is a postfix notation. Suppose you want prefix notation from this tree. Prefix. You want prefix notation, prefix order. You see here. 9. 9 is the first visit, 5 is the first visit, 4. We can start from the 4. 4 is the prefix, sorry, okay, infix, sorry. Okay, what is the next one? Infix. Next, infix. Infix is, you see, 9 is the first visit, 5 is the first visit. We need to consider second visit for the infix. Prefix means first visit. Postfix means third visit. For infix means second visit. Infix means second visit. So 9, 5. So here option 4. 4 is we'll start with the 4 and second visit 5 and 3. 3 is the second visit. Next, similarly, 5, again 9. 9 is the second visit and 8. 8 to 2 is the second visit and 1 is the second visit. That's it. Okay. Now 8 and 9. Sorry, 8 is missed here after 2. After 2, again, 8 is the second visit. After 2, 8 is the second visit. And after that, 1. So this is what? Infix notation. See, try to observe the root node. The root node 9 is, in a prefix notation, starting is present. In the postfix notation, it is a last is present. In the infix notation, it is a middle. So for the left hand side again, you see here 4, 5, 3 are the 4, 5, 3 are the left hand side and 2, 8, 1 are the right hand side elements. Understood? So for any given tree, we can able to find out the infix, prefix, postfix, and infix. So that is based on the roots here. Okay. For any node, node will be like this. Okay. Some left child, some right child. Okay. This is called first visit in this place. In this place, this is the first visit. In this place, this is the first visit. And in this place, it is a second visit. And if you come to here, now this is a third visit. If you understand this one, you can solve any problem. So this is the first visit. And after coming here, this is a second visit. And after coming here, this is a third visit. So this is how we can write from the given tree to infix and postfix notations. Clear? Clear? Any doubts? Any doubt still? Okay, thank you. Next, we can solve one more problem. Okay, let us go for the one more problem. Uh, so now sometimes suppose what they will give you is sometimes they will give you degree of the node. Okay, degree of this node, and they will ask you that construct the tree, construct the tree. So let us see that here. C and B, C, B, again B and A. So let us take, they are giving like this. And for C, we are giving 0. And for the degree, this is a called nodes. These are the just nodes. And these are called degree of that node. So for the C is a 0 and B it is a, okay, both B and R. Wait. C, D, C, D, B, A. And for the D also 0. And for the B degree is 2. And for A degree is 1. For degree of A is 1. Now, what I want to generate is, I want to generate the tree. I want to generate the tree. I want to generate the tree. So try to tell me. So degree means what? Number of edges that are incident from that node is nothing but a degree of that node or vertex. Okay. So here B means B degree is how much? 2. That means I can say this one will become the, can I say root node or not? Because the B is, it cannot be, okay? B is having 2 children. So this degree means, yeah, actually B is having 2 children. C is having 0 children. D is having 0 children. And A is having only 1 children. A is having 1 children. And the sequence also, it need to mention actually, whether what type of sequence it is. Let us assume this is a post-order traversal. This is a, otherwise you will get different trees. You should It is a post order tree. It is a given sequence is a post order, and also it is given degree. That's it. They have not given infix. So just they have given postfix notation and degree. That's it. I need to find out the tree. Now you see here. So that means for the post order, whatever the final one that is called as a root node. Can I say yes or no? A is a root node. So that means I can say that A is the root node. A is the root node. Without any second thought, I will give you A is a root node. Okay. A is the root node. That's okay. I don't have any issue. Next, what is the degree of here? B is a 2. That means can I say B is maybe either present a left hand side or right hand side. I don't have any issue because uh, post order. So that means here there is a chance of getting B here. B. Because B degree is how much? Two children's. And two children's means so B is it may be anything, left or right, doesn't matter, okay? So let us take C is the left. Okay, if you want the C is the left child and right child notation. No? C is the left child and also D. So this is a tree I have generated by taking the this post order traversal, and they have given degree as well as here. All are satisfied. You see here. A is having one child only. B is having two children. Yes. And C is having zero children. So D is having zero children. So this is what a tree that is generated. Tree is generated like this. For the same thing, can I also write like this? This tree, this is also possible actually. A is the node, and you can write this is in the right side also, no issue. B, after B, it is having C and D. This is also a tree. This is also possible. Same thing. This A may present left hand side or right hand side. It doesn't matter. Okay. Like this, we have one more problem. Okay. Same type, we have a one more problem we will solve it. So let us take, I am giving one more problem. You try to generate the tree. So D, 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 E, D, F, G, C, A. These are the D, E, F, B. So D degree is 0, E degree is 0, and B degree is 2, B degree is 2, F degree 0, and G degree is 0, C degree is 2, and A degree is 2. So try to generate the tree, and it is a post order traversal only. The given one is post order, post order. So you people try to generate the tree. I am giving here D sequence is 0, E 0, B 2, F 0, G 0, and C 2, A 2. So what is a root node? Root node definitely without any second thought what? A is a root node. A is a root node. So here A is the root node And for this A, we are having A is the root node. Okay. A is having how many children? Two children. Okay. That is left child as well as right child. A is having both left child and right child. Now tell me which one will become the left and which will become the right. Definitely it is a because you see here degree 2. Definitely for A, left child will become B and right child will become the C without any second thought. Okay? So B, because they here infix is not at all given. So that's why I'm taking decision based on the degree. C. Okay. B, C. Now BC is done and remaining all are left nodes, okay? Zero nodes only, okay? For the B, for the B, D, E, F are left hand side. So I can say D, for the B, we have a D as well as E. D is the left child and E is the right child. And E is the right child. And for C also, you see here. For C, we are having F is the right child, G is the left child. F is the left child and right child is G. You see. So this is the tree that is generated for the given post-order traversal as well as degree. So now you check here, A is having degree 2 or not? Yes. B is having degree 2, C is having degree 2, and A becomes a root node. The post-order last one becomes a root node. I already. Okay. So for the B, what is a degree 2? So that is for the D, what is the degree? 0. For E, what is the degree? 0. For F, what is the degree? 0. For G, what is the degree? 0. So this is what how we can generate this tree. This is called as a post order traversal and degree. We are generated unique tree. This is a unique tree. So like this, we have some gate questions. And let us see some more questions. Understand this problem? Not yet. Any doubt? Any doubt in this type of problems? If you have any doubt in this type of problems, you ask. Okay. Next one is, we will see that identify whether the following are, I think you know the binary search trees. Okay. In the data structures, we have a binary search tree. What is the concept of binary search tree? So here we are going to see here. We clear this one. What is a binary search tree? I think we don't have any doubts in this problem. If you have any doubts, you ask me please. Okay. Let us write one more thing. Binary search tree. Binary search tree means you know that very well. Left hand side, a node which is having left child is having lesser values and the right hand side is greater values. Now in gate question, there is some very good problems are there in this one. Okay. The time per minute, permit or not? In 50 it is there. Okay. Okay, anyone is having any doubts? You please ask me that. If you have any doubts before the time is not sufficient. So meanwhile, if you have till now any doubts in this problems, you can ask before going for the next problem. Okay, students are also. Okay, if you have any doubts, you can ask. If you have any doubts, you can try to place for this 5 to 5 minutes, and later we can close this session because if I start the problem also, it will be in the middle of the problem only. We are not going to complete. So we can, I can try to answer any queries if at all is there. Okay. Uh, okay, sir. Can we close the session? Meanwhile, you can, if you have any doubts, you please ask me. And and one more thing in this gate questions, you try to always options you have to use is eliminate wrong options. That is the best strategy. Instead of searching the right answer, you try to eliminate the wrong answer so that right answer automatically you will be selected. If you are slowly avoid eliminating the wrong options because we have a negative marking. So what you need to do is you need to eliminate wrong options so that your questions will be answered correctly. Okay, right. We will close the session. Meanwhile, if you have any doubts, you can chat. At least if you are not asking, you can text me if you have any doubts. Okay.